Hello students, the next part of learning algebra is learning about the difference between relations and functions. And so we have this foldable that you've already folded and cut, and so we are going to write on the outside and on the inside all the things that you need to know about relations and functions. So the first thing we want to do is to define what relations are. And so we're going to do that. Relations are algebraic models that describe how two quantities relate to one another. I'll say that one more time. Relations are algebraic models that describe how two quantities relate to one another. Now, most of the time when we talk about relations, we're going to talk about the x, y that we find in most ordered pairs or coordinate planes. When we graph all of those things, excuse me, we're going to look at the x and the y and how the x is related to the y. Okay? So now let's look at functions, because functions are a subset of relations. Not every relation is a function, but every function is a relation. Okay? So let's talk about a function. Okay. So the function is a relation in which each member of the domain, new word, is paired with one and only one member of the range. I'll say that one more time. A function is a relation in which each member of the domain is paired with one and only one member of the range. Okay? So what you probably want to know now is the domain and the range. Well, the domain is always going to be the set of x's in the xy pair. And the range will be the y. So every time we talk about the domain, we're talking about the x's, and every time we talk about the range, we're talking about the y's. Okay? So now, you can represent functions in lots of different ways, and we're going to talk about 4 of those ways right now. So we're going to open up our foldable, and we're going to look at the 4 different ways that you can represent functions. And I think you can see all of those. Okay? And so let's start at the top. At the top, you probably are looking at these and you think you recognize these, and we call those what 2 words? Exactly. Ordered pairs. Okay? Ordered pairs would be an x and a y in parentheses. Remember, it's very important that you put them in parentheses, and they're separated by a comma. The x tells me that I'm going left or right along the x-axis, and the y tells me I'm going up or down on the y-axis. So I have 2 sets of ordered pairs. We've got the top one and the bottom one, and we've got to figure out which one of these is actually a function and which one is not a function. They're both relations because they're comparing the x and the y, which is a function. So if we go back to our definition of function, a function is a relation in which each member of the domain, each x, is paired with one and only one member of the range. So is each number of the domain paired with only one number in the range? Another way to say that, and I should have written that down here, and I'm going to put it in parentheses on the front, x cannot repeat. I'll say that again. In order for it to be a function, the x cannot repeat. It doesn't matter about the y can repeat all day long, but if it's a function, the x cannot repeat. So in this set of ordered pairs that I have up here, do any of the x's repeat? Why, yes they do. The -2 is in there twice. So this is not a function. So let's look at down below. Are there any x's that repeat? No, they're not. A negative 2 and a positive 2 are different. They do not repeat. So this is a function. Okay? And again, ordered pairs, set of ordered pairs in parentheses. So let's go next door. Next door, what do we call these? You're right. Tables. Well, I hope you're right. I didn't hear what you said, actually. So we have tables. And so let's look in the table. Same thing. We're looking at the x's and the y's. Does anything in the x value repeat in this top table? No, nothing repeats, so it is a function. Now you're going to say, well, the y repeats. The y doesn't matter. It's only in the x. So this is a function. We're going to write that. And this one is not a function. I guess I probably should have looked at it because the 1 is repeating. Okay? So notice the difference between ordered pairs and tables. Ordered pairs are in parentheses separated by a comma. Tables are in 2 columns. Sometimes you might see tables written long ways where the x's are on top and the y's are on the bottom. Those are tables. And you got to know all of these because you're going to be able to transfer between each of them. So let's look at the bottom left-hand corner. I think you can see it okay. These are called graphs. Okay? Graphs. Now when we look at functions or not functions on a graph, there's a test that we can use, and we're going to write it over on this flap, and it's called the vertical, I don't know if you can see that, vertical line test, or the VLT, like I like to remember because I love BLTs, so I just call it the VLT, the vertical line test. So here's the vertical line test. If a vertical line drawn anywhere on the graph passes through, and I know I spelled through the wrong way, more than 1 point, it is not a function. I'll say that again. If a vertical line drawn anywhere on the graph passes through more than 1 point, it is not a function. Now remember, vertical lines go up and down. So I can look and I can see if I can draw any vertical line, and do I pass through more than 1 point? Well, if I draw a vertical line, you can draw this or you don't have to draw it, doesn't matter. I'm just going to demonstrate. If I draw a vertical line right here, it passes through 2 points. So that means it is not a function. Now, why is that? Because if you look at this point right here, the ordered pair is 4, 4. And if you look at this point right here, the ordered pair is 4, -2, and both of those x's are the same, 4 and 4, which means the x repeated, which means it's not a function. So we can just look here on the vertical line test to see. So let's look here. Can I draw a vertical line and pass through more than 1 point? Nope. So this one is a function. And then the last we're going to look at might be new to you, may not, but this is called a mapping. Okay? And there are 2 very important things about the mapping that you have to have or you will be incorrect. With the mapping, you must have ovals and you must have arrows. Okay? The left is the domain and the right is the range, or the x's and the y's. But you have to have arrows drawn from the domain to the range. I know it's really hard to tell, but all of those have arrowheads on them because they're pointing to which number it's going to. If you don't put arrows, then I don't know which direction you're going, and I don't know which one's the domain and the range, and you get it wrong. You have to put an arrow on the end that is pointing to the range. Okay? So let's look. If I took a mapping and I wrote down all of the ordered pairs from this mapping, I'm going to do that over here. The 6 goes to 1. So the first ordered pair is 6, 1. The 9 goes to the 11. There's another ordered pair. The 10 goes to the, maybe that's a -4. I don't know. Either one doesn't matter. And then the 12 goes to 0. And the 17 goes to 2. Did any of my x's repeat? No. But that's how you find the ordered pairs. I think that really is a -6. I'm old and I can't see well, so we'll pretend it's a -6. It doesn't matter, still not repeating. So this is a function. Now mapping, this is where it kind of gets tricky. So if I look here and I write down all the ordered pairs on the mapping below, I'm going to start with the 4. The 4 goes to 10, but the 4 also goes to 5. And the 2 goes to 10, and the 7 goes to 5. Is that a function? You're right. Why? Exactly. I heard all of you say because the 4 repeats and the 4 is an x. So not a function. So there are two things that are important through this lesson. One is you have to know how to identify a function by looking at the x values or the vertical line test. The second thing you need to know is how to write ordered pairs from a set of ordered pairs, from a table, from a graph, and from a mapping. Those are all of the things that are important when we're talking about relations and telling whether a relation is a function. And that is all for this video, but we'll continue to build on this through the next one.